So Nginx on AWS, let's get into that. So what we're going to talk about here just quickly, kind of who's using Nginx on AWS. Well, it's people in the room who raised their hands to start off with. Startups, enterprises, government agencies, we talked about that before. There's really a lot of usage going on AWS in general. And then one example I want to kind of zero in, and this may be familiar to many of you, but I think it's a really cool thing, especially after I've talked to some of the people in our team who actually worked on this directly. The NASA Jet Propulsion Lab, the Mars Curiosity mission. So that was when they actually landed the Curiosity rover on Mars. NASA wanted to be able to live stream, or as close to real time as possible with data coming from Mars, live stream those video images and those still images to people who are accessing their website and be able to stream it and see it around the world. And so this actually comes from a case study that's on the AWS website. You can just go to search on AWS and case studies. And in this architecture, I know it's kind of big, but the Nginx usages are kind of at the middle and the bottom of each of those. So what you have is they're deployed in multiple regions, multiple availability zones within those regions, and each one of those columns is a standalone stack within each of those availability zones as well. So Nginx in this case is acting as the secondary and the mid-tier caching for supporting all of that data and then getting it out and delivering it through our content delivery network out to the people who are requesting the information. So pretty big usage of Nginx. And I mean, this got a lot bigger than what you'd see on this screen here. They would just keep spinning up stacks as they saw the traffic and the needs coming out as far as people trying to stream this data. So pretty cool thing. Okay, where Nginx fits. So this is kind of a example of we call it classic web tier architecture. It comes from our best practices with web architecture white paper, and Nginx can fit into a lot of places here. You've got the load balancer, the web tiers, the caching, the content delivery. A lot of that's been talked about in some of the presentations over the last couple days. I'm going to talk about some areas where Nginx fits into this diagram. Won't cover every one of them, but this is kind of level setting some of the areas where it fits when you start talking about some of the classic web architectures. So installing Nginx Plus on AWS. So Nginx Plus is available through the AWS Marketplace, just aws.amazon.com/marketplace. From there, you go search on Nginx Plus, and you'll have the option. There's two different machine images. There's either on Amazon Linux or Ubuntu. There's actually a 30-day free trial for the product out there right now, so you can spin it up, launch it for 30 days, and you're only paying for the EC2 hourly rates, not the Nginx part. So a great way to go out and try that. Launch those instances and do a quick verify with the normal Nginx status, and it's immediately ready to take the public IP address of your EC2 instance, drop it into a browser, and it'll serve up the index page. So getting that launched is a pretty straightforward process. So want to dive into some security recommendations. Now that you've got your EC2 instance up running Nginx, first thing is just really using SSH for accessing all your hosts. If you're really good, even not using SSH at all, if you've got yourself to that point operationally. But using SSH, individual SSH keys for each person who's going to access that host, it really, by using that and staying away from username and passwords, you're really protecting yourself from brute force or dictionary attacks against your instance if it's a publicly facing instance. And then using security groups to control your inbound and outbound traffic. So when the Nginx instance launches through the marketplace, by default, you're given these security groups control inbound and outbound traffic to your EC2 instance. So by default, you're given these security groups for these various protocols and the port ranges for your HTTP, HTTPS, and the various forms of SSH that are listed there. But the source IPs for these by default is fully open to 0.0.0/0. What you're going to want to do is you're going to want to lock those down, especially for the bottom three around the SSH parts to maybe your corporate network, or even go deeper on some of the stuff for rsync and corosync to maybe only the other instances that actually need to use those. Or if you're not going to be using them, just delete them. But keep that in mind when you first launch the instance. If you're just going to launch it and play around with it, the risk is kind of low. But if you're going to start using it sort of a test or production environment, you're going to want to think about hardening those and making sure you've got it configured the way you need it. Okay. So load balancing. There's been a lot of talk this week about using Nginx as a load balancer. We'll talk about a couple of different use cases here. The first is behind an elastic load balancer, and that's a pretty common one. So we've got In this case, we've got a Route 53 hosted zone that's interacting with an elastic load balancer, and we've got a couple of Nginx instances behind that and an auto-scaling group, and then they're just serving up traffic to a web app. So pretty straightforward usage of Nginx there behind a load balancer, using Nginx in whatever way you need to use it after the traffic is handed to it. The other use case is that there's actually, you can use Nginx itself as your load balancer. If you choose that it's giving you what you want don't want to use elastic load balancer, totally fine. In this example, what we've actually done is we've got an elastic IP address, which is just a public IP address that you can allocate within a region within your AWS account. You can take that and attach that to the instance. You can actually reattach it to other instances, and the IP address remains the same, and you can change out the infrastructure behind it. We'll talk about a few examples of why that might, how that might be happening in a few minutes, but you can use your elastic IP address, route that to your Nginx load balancer, and then that can take and serve the traffic off to the web app the same way. Yes?
Do you have to pay for 2 Nginx Plus licenses if you want to fail over like that?
Yeah, so if you wanted 2, like in this presentation, yeah, so there's each one of those is basically an EC2 instance. So if they're both running, you're paying the hourly rate for each of those. You could have one configured and just stop it, and it's there and it's configured, but if it's not running, you won't pay the hourly rate. So you could have just one running. Yep. So a couple of considerations if you're going to go the do-it-yourself route from a load balancing perspective. And really, the main thing is that Nginx isn't auto-scaling aware. So if you've got an Nginx instance serving as your load balancer, and you've got other application servers behind that, and they're actually configured for auto-scaling, they're gonna that auto-scaling group's gonna scale out, and Nginx isn't gonna be aware that there's additional instances that it can now serve traffic to, or even worse, that there's instances that have left the fleet and it can't serve traffic to them anymore. So you're gonna want to do, there's a couple different ways you're gonna want to make sure that you're auto-scaling aware. That, the simplest one is human. If you don't scale up or down very often, you could just send notifications to a DevOps person, and they could go in and change the configuration on your own. But if you want to automate it, there's a couple different ways. One is just writing a small script on your Nginx instance that's going to call some of the command line tools around describe auto-scaling instances. It's going to tell you every instance that's currently in an auto-scaling group. And then from there, you can call the describe instances to get the IP addresses of any new instances, and then you can update your configuration for either instances that have come into the fleet or left the fleet. You can also, we've got several software development kits, Ruby, Python, Perl, and all that, or not Perl, but Java, that you can use instead of the command line option if you want to do these same things. The other option is really using our queuing and notification service to kind of give your Nginx instance awareness that things are coming or going from the auto-scaling fleet. So in this case, we've got our current state Nginx serving up traffic to a couple of other instances in an auto-scaling group. What you can do is actually, when a new EC2 instance launches, there's a piece of functionality called user data, and you can actually embed scripts into that towards the end of launching an instance, it'll actually execute on those scripts. And one of the things you can do in that script is just have it send a small message to the Amazon SQS, the queuing service, that says, I'm launched, here's my IP address. And then your Nginx instance can actually just query that queue on a regular basis, find the message that there's a new instance, take that information and pop it into your configuration to serve traffic to that new instance. And then when you're done scaling up and you need to scale back down, you can configure your auto-scaling rules that anytime you remove an instance from an auto-scaling group, it can send a message to simple notification service. And then you can subscribe a queue to that message, and it will dump a message into that queue and said, hey, this instance has left the fleet. Here's the information. Nginx can query that queue and remove it from your configuration so that you're not serving traffic to it anymore. Yes? Yes. There's command line, so you could use the command line tool, or we have one of the SDKs to just call, here's the name of the queue, tell me if there's anything in it. If there is, give it back to me, I'll read it, and then I'll delete it. Or you can leave it in there, and they expire after 14 days. There's several different ways of accessing that information, yes.
So you mentioned like a cron job that does that very well?
Yeah, it could be a cron job, yeah, certainly. Yeah. Yeah.
So in one of those scenarios, the Nginx server has to constantly pull a source in order to get the data. Even in these auto scales, you still have to restart the Nginx service so it picks up the new or the removed nodes?
Yeah, so also, as far as knowing about the groups?
Yeah, so it's in your second one,
Mm-hmm.
from 2 to 3,
Mm-hmm.
and it pulled that Amazon SQS to
Right.
get the new one was added to the pool.
Mm-hmm.
So, but you still have to add it to the upstream in Nginx and restart Nginx in order for it to start balancing traffic to that new node, right?
Yes, so it'll have to be in the configuration, and maybe you can help clarify on that. Yes?
Out of curiosity, like how wide are the auto-scaling groups traditionally distributed? Should we think of them as sort of a LAN, or do they get wide?
They can get really wide depending on how much traffic you're putting through them. So we'll talk about some of the sizing things, but part of it depends on how big your instance is from a CPU and a memory perspective. Like you could be using our really tiny T2 micros, which are really cheap but don't have a lot of power, and just scaling them out way wide. It might make more sense from a processing and a financial perspective, or you could just choose smaller, really massive machines where maybe you don't scale as often, but when you do, you're going to bring a lot of horsepower in at the same time. So it's really kind of depends on your configuration. We'll actually talk about that, and maybe even testing some different profiles that'll help you figure that out. Sure.
One follow-up. So SQS.
Yep.
Is it? I mentioned someone. I heard someone say polling.
Mm-hmm.
Are you guys still using polling on the consumer side for messages? On SQS?
Help me understand a little bit. So.
Okay. So like, I think of queuing where it's just the message appears. That's it. You don't actually actively poll for it.
Yeah, you have to pull SQS to say, is there anything for me? And it's got a lot of cool functionality. You can lock messages. So if you've got multiple servers reading the queue, you can make sure that they don't both pull the same message and stuff like that. But you're pulling the queue actively to say, is there anything for me to work on? Yep. Okay. So with that, we kind of talk into performance a little bit and EC2 instance sizing. So for the white paper, spent a lot of time talking with Rick about what kind of recommendations can we give people that say, this is the EC2 instance size you should use based on this profile. And what we really kind of figured out is that there's really no prescribed formula that says if you're going to do this, you have to have this. So the recommendations that your workloads are going to vary. So start small and move up. With AWS, it's very easy to, with a click of a button, say change instance type and go to a bigger instance for your existing configuration. In a few minutes, you're running on that larger instance type. So what we've seen and what we kind of recommend is from a testing perspective, start really small. If you're just going to get Nginx going, you're going to play around with configuration and really make sure that things are going to work. Start with the T2 class of instances we have. They're really small. Some of these are like 2 cents an hour for you to run and play with and just kind of get things working and make sure that everything's working end to end. And then you might go to your initial launch, maybe starting on the general purpose instances, the M3 class, which kind of, as I said, they're just general purpose. They've got a little bit of some CPU, they've got some RAM. Maybe that's a good fit. And then when you kind of get to your steady state, you may find that you're going bigger. So just getting a larger instance to get more memory, get more CPU, or that you might just be adding more and using auto scaling to just add more processing power to your overall fleet. It really just kind of depends on the workload and the profiles that you're seeing. There was a great presentation by the Datadog people yesterday that kind of talked about usage of what they're seeing of kinds of instances that people are using Nginx on. If you guys go back and reference that, there'll be some good information there. I think the compute class were at the top of that list of things that they showed. So, and with that, we've got the broad set of instance types. So we've got the general purpose instances. We've got our compute optimized instances if you really need a lot of CPU. We've got the storage and I/O optimized. These are really, really big with a lot of internal SSD storage. The GPU enabled, which are really the graphics processing instances, great for a lot of some of the gaming industry starting to use it in scientific analysis. And then the memory optimized, which have a lot of memory for you to use if you need it. And then around performance, this has been talked about several times over the last couple of days from a traffic profile perspective. If you're going to be doing things like SSL termination, a lot of small requests, or things like WebSockets, you're going to want to be looking at make sure you have enough CPU resources. That's probably be a better deciding factor of what you're going to do. Content caching, memory, and maybe even instance storage might be a deciding factor from you. And then if you're really getting bandwidth heavy, you might even be looking at just straight out horizontally scaling with auto scale so that you aren't saturating the pipe of any one instance so that you can keep things going. All right, performance planning. So we already talked about determining the right instance profile, testing. I'm a really big advocate of testing, as you can see. Running your expected and your unexpected traffic patterns against your environment. So when I say unexpected, I'm referring to things of like, what if you got flooded with a massive amount of requests all at once? How is your auto scaling going to react? And are you going to scale up in time to be able to handle those requests? Trying that out and seeing what happens. If it doesn't work, then maybe you need to change your alerts and your metrics to start scaling sooner so that your fleet's ready and available to handle all the traffic that's coming in. So try out things that you just don't think might happen, but to see how you're going to react if they do happen. Analyzing the results, tweaking where you're needed, throwing away what doesn't work. If you're finding that you've chosen an instance and you flood it with as much traffic as you possibly see and it's just sitting there smiling, maybe you need to go to a smaller instance that's not as expensive and see what happens, or if it's falling over quickly to resize that instance. Once again, there's been a lot of talks around this weekend. I don't think that I'm saying anything hugely different, but a big thing that I advocate for when you're getting started on this stuff on AWS. And then finally, monitoring. Using whatever monitoring solution works for you that you like to use. We'll talk about the AWS one in a minute, but monitoring your testing, but also monitoring when you're in production, actually paying attention and knowing what's going on in production to see if you're actually achieving the traffic patterns and achieving the performance you expected, or if something different is really happening. Performance baselines, most of these testing tools have already been mentioned, but a few tools that are available to you, of course, your own favorite tools. Big thing is just pick what works for you. Pick what's going to give you the information you need, allow you to test your application that's going to give you the best results. Some baseline approaches as far as AWS. First one, make sure you're testing from a different instance than your Nginx instance is running on, so that you're not giving yourself abnormal metrics, so that you're not hogging resources that your Nginx instance actually needs to execute the tests on. Next one, try testing from a different availability zone. So launch your test instance in one availability zone, your Nginx instance in another availability zone. It'll help you just flush out if you've had any traffic issues or things that you didn't think about in configuration that don't act properly when you've got traffic coming from another availability zone. You might have applications in that other availability zone. And then finally, testing from another region. So when you start testing from another region, that's actually over the public internet. So you're going to have traffic coming from one region into another region over the public internet. Potentially help you flush out anything that you didn't think about when you've got traffic coming in from that side. It gets a little bit closer to helping simulate a real user profile if you're going to be standing something up public facing. Okay, so some general recommendations around high availability when it comes to AWS. First one from an architecture perspective is just using multiple availability zones in a region. Standing up copies or having maybe a pilot light or a warm standby of your application sitting in that availability zone helps to guard you in case there's ever any issues where the availability zone becomes unreachable or unhealthy. You can fail over to your applications in the other availability zone and continue on with little to no interruption of your application or service. The next one, which we've talked and preached already, is just really using auto scaling to help you with load changes. Allows you to help scale up, scale down, and allowing your application to be able to continue to serve traffic and do its job without impacting your end users or your services. So within Nginx as well, Nginx Plus, there's actually a high availability configuration that's available. And what this does is it gives you a highly available pair of Nginx instances running on EC2 that are tied to a public elastic IP address. It's an active passive configuration, and it's using CoreSync and Pacemaker to help manage the clustering of those instances. So this is just a representation of what it looks like. You've got your traffic coming into the elastic IP address, pointing to a primary instance. CoreSync and Pacemaker are managing what's going on in there, and that dotted line represents where traffic will be routed if the primary ever was detected as being unhealthy or unreachable by CoreSync and Pacemaker, and it would switch the elastic IP address over to that standby. By default, when you install this, the timing on CoreSync is a second. So it's polling every second to see, can I reach that host? If you ever do this, easy way to test that that's working after you're in AWS is get everything working and just stop the primary instance in AWS in the console, and then you'll see the elastic IP immediately switch over to the other instance.
Is that a service you have to install yourself, or does Amazon provide that functionality? Like, do you have to go in there and install Pacemaker or Keep Alive?
Yep. So we're gonna hit that right now, actually. That's all right. So it's all provided by Nginx. So the way this is going to work, you're going to allocate an elastic IP address in the region that you're going to run in. You're going to create what we call an IAM instance profile, and this is really for assigning and deassigning and doing some describes on the EC2 instance. And what this allows you to do is you're going to tie this, you're going to assign this profile to the EC2 instance, and it's going to basically grant permission to anything running on that instance to be able to make those service calls without having to have actual user keys stored on your server, and it's just a little bit more secure, and it gives you that flexibility to say, okay, I grant anything that's running on here the ability to do that. So you're going to assign that IAM instance profile, your EC2 instance, get those instances launched, and then you're going to install Nginx HA. There's the yum and the apt-get commands that are there. You're going to start the configuration on both instances. So what you're going to have both instances up in your console. You're going to run this setup command. It's going to start asking you a series of questions. It's going to ask you, what's the EC2 instance ID of the other instance that's going to be in my cluster? So you're going to put the IDs in each of the console windows. It's going to ask you what's going to be the host name for each of the hosts. You're going to define that. This is just going to go through doing some installs and configurations of CoreSync and Pacemaker for you. You'll be hinting enter a couple times on each of the consoles to get that going, and then it's going to ask you which instance you want to be the primary. It'll ask you to generate a key on that instance. You'll paste that key into the other instance, and then it'll ask you which elastic IP address do you want to use of the available ones in your pool. You'll choose that. It'll go through a little bit more work. It'll start Nginx on the primary. It'll shut Nginx down on the secondary, and you'll have your cluster available for you to use and start doing traffic. Now, just keep in mind, in this case, the secondary is actually running. The EC2 instance is running. Nginx isn't running, but the EC2 instance itself will be running so that it can immediately flip over, as well as do that monitoring on that primary. And then this is your, on the right, basically an example of the configuration verification that you would get after you've done it to see that you can run this from either of the hosts, and you'll see it'll say these are both the hosts in the cluster and that they're running. Quick example of what that architecture looks like. You've got your elastic IP coming into the primary serving the web apps, as well as your failover. In this case, I've put the failover in another availability zone. So, the primary, you might have a situation where the primary is just fine, but the availability zone itself is having issues that would also allow you to fail over to another instance and keep running. And another option, so elastic IP addresses are only at the region level. You can't have one elastic IP address that points to resources across multiple regions. But what you can do is use something like Route 53 to actually configure, you could use latency-based routing, geo-based routing. You could have a DNS failover that allows you to actually have this configuration in multiple availability zones in multiple regions, each with their own elastic IP address. And Route 53 can take care of routing that information to the right elastic IP address based on the rules that you've configured in Route 53. So these are definitely not the only two ways to do it, but a couple of recommendations around using that particular piece of functionality within the product. Some additional considerations. Make sure that both your Nginx instances are actually configured to do their jobs. So you've got the primary running and taking traffic, but as you make configuration changes or software pushes, make sure that secondary is getting the same updates. So as soon as it takes traffic, it can start doing the same thing without any interruption. And with this configuration, you're going to get an active-passive with two instances. If you want more instances or active-active, you're going to need to dive into the CoreSync and the Pacemaker documentation to figure out how to get that working. Okay, monitoring. I've already talked about kind of knowing what's going on in your environment. With Amazon EC2, these are the default metrics that you get anytime you launch an EC2 instance. These are the metrics that are available to the hypervisor. By default, you get them in 5-minute intervals, and you can make a configuration change when you're launching the instance or after the instance is launched to start getting those in 1-minute intervals as well. Additionally, there's now an agent that's available to actually take the information from the status.html page that you would get from Nginx and actually put that information in the CloudWatch as well. So this is a quick overview. You would just install the agent either through yum or apt-get to get the agent onto your Nginx Plus instance. You're going to update the configuration file that's delivered with that install. The name there in the example is really what it's going to result in the namespace. So when you go into CloudWatch and are searching for custom metrics, that name will be the namespace that you're looking at in CloudWatch. And then you're going to give the URL of where your status page is located. There's also another example here. If you've got a username and password that you're protecting that site with, you can put those into the configuration file as well so they can still be accessed. Then you're going to start your background agent. There's two options here. You can run it kind of in a test mode that'll actually give all the output to the screen so you can actually make sure that it's working or review any errors that are happening. And then when you're ready to go all in, just start the agent and it'll start sending the metrics into CloudWatch. Quick note back on the configuration, there is one other configuration thing you could change, which is the timing of how often the agent's looking for metrics. By default, that's 30 seconds. You can change that and it'll influence that. And then you can go into CloudWatch and you can view your metrics. You can view them all together or view them one at a time, depending on how you want to do them. You can also now, you've got these metrics in CloudWatch, you can create additional alarms based on the information you're seeing. You could have it simply send emails. You could maybe come up with an alarm that helps you kick off an auto-scaling group. It really depends on what's important to you and what matters as far as monitoring goes. You could also, once this is in CloudWatch, pull it all out, use one of the other monitoring solutions if you're already using those to pull that information out and view it how you need it. Okay, and next part is CloudWatch logs. So this was a new feature with CloudWatch that came out around middle of July. Actually allows you to consolidate your metrics and alarming from the log files that you're generating. So with Nginx, by default, you've got your access and your error logs that come with that. You can actually define filters that'll parse the content from your log files. I'll show an example of that in a minute. So you tell it what's the structure of the fields in the log file, and it'll be able to take each one of those and turn it into a metric for you to view. You can then view those, or you can create alarms based on those. That'll tell you. You can once again use auto-scaling rules or send emails, but whatever alarms are important to you based on those metrics. And you can define a retention period for your log files. So if you've got some sort of compliance that requires you to maintain your log files for a specific amount of time, you can configure that retention period as long as you want, or just for a few days, depending on how important those log files are to you. A couple of examples that show up pretty well here. So on the left is the filter. So that's for the access log. And just telling it what is the structure of the access log, what's in each field in the access log that's being delivered to CloudWatch. And then the alarm, I just configured a really quick test alarm here on 400 errors to just tell me, alarm when my 400 errors crosses this threshold within this 15-minute window for the log files that are being delivered. As far as CloudWatch logs itself, it just involves installing a little agent onto your EC2 instance. And giving it either using an instance profile that we talked about earlier or giving it some access keys so it can start sending metrics and log information off to CloudWatch. You also have the ability to have a one-to-many relationship here. So you could have an entire fleet of Nginx instances that are just doing the same thing. You could send all the logs for those into CloudWatch, and you can group them together so that they're one metric that you're measuring against. So you might be looking at 400 errors, but you might be looking at them across the entire fleet. And this will give the ability to do that by looking at all those log files as a collective. Okay, a quick note as far as a backup strategy goes. In AWS, you've got your configuration working. You've invested all this time to get things working, so make sure you take care of it. Make sure you can recover from it. Make sure you can use it again. You can create a machine image with each of your new verified configurations. So if you deploy a configuration to production, this is good. You can create an Amazon machine image and really just say that that's my new golden image. Anytime I launch a new Nginx instance, this is what I'm going to use. You could also create a snapshot of the root volume. So we talked about elastic block storage earlier. The operating system and the configuration is all on block storage. You could do regular snapshots of that and actually use that as your block storage the next time you launch an instance. You could store your configuration files in S3 or any source repository you use, and then just use the user data functionality I talked about earlier to actually, when the instance launches, tell it to go out and get your configuration files from whatever repository you use and deploy those and configure those on your Nginx instance. Or you could use tons of configuration of continuous deployment options and software out there to create new machine images every time you've got a new configuration out there and have those as your golden image. So lots of different choices out there. I'm sure there's probably 3 more slides of ways people would implement that or could implement that here, but just a couple recommendations. So with that, I know I'm standing in between beer I'll wrap it up here. First of all, just thanks for your time. I really appreciate it today. Quick call out here at the bottom there is the AWS pop-up loft. So any of you who are going to be sticking around San Francisco for a while or call this home, the AWS pop-up loft reopened October 1st, and it's going to be open for a whole year. Feel free to stop in. They've got an Ask an Architect bar where you can pop in and ask. We've got solution architects local and people who come in all the time. Just ask them questions, or they can talk to you further about AWS in general. And there's lots of events that are going to be going there throughout the year, boot camps on using AWS or various services. So I recommend you check it out if you're going to be in town at all for a while. So with that, I'll answer any questions you guys might have. Thanks. Yep.
So one thing that is not mentioned about ELB, that when you are using ELB, the IP address will change. How often does it happen?
So we'd recommend that the DNS of Elastic Load Balancer will change. So behind that is just, we don't recommend that you take that and embed that somewhere because it will change.
Right, which is a problem, because when I have an Nginx instance with a public IP, the public IP will never change, unlike the IP address associated with the ELB.
Right.
So what are you guys making any effort to assure that the old IP address still works while you transition to the new one?
So that the Elastic Load Balancer, that that IP address doesn't change?
No, so when you assign a new IP address to the name, making an effort to make sure that the old IP address still works, because I can have long-lived connections.
Oh, you're talking about like if you choose like a new Elastic IP address?
No.
Okay.
It happens within ELB, the IP address changes, right? If I have an ELB name, that is a C name, which is behind that another C name with a bunch of IP addresses.
Right.
Those IP addresses change.
Yes, they do, and that's why we recommend that you just use the overall name of the ELB when you're routing traffic to it and not using those IP addresses, because they will change because we're bringing resources in and out, scaling things up and down to meet loads.
Right, which is a problem if you have a long-lasting connection.
Okay. We should trade information. I can probably look some things up and talk to the service team a little bit more to make sure I'm answering your question right. I don't want to leave you with bad information. Let me get your information when we're done here. Okay, other questions? All right, well, thank you, everybody. I appreciate your time today.